Good morning, geometry students. I'm creating this video as a supplement to the special segments section in Edgenuity that you guys are to be working on today and tomorrow. In the previous lesson, it reviewed angle relationships from chords, secants, and tangents. In this section, it goes over segment relationships between chords, secants, and tangents. So the first one that they introduce is the chord-chord segment relationship, when you have two chords in a circle that intersect each other. Looking at our general diagram that we have here, one of our chords is A, B. Our other chord is C, D. And the chord-chord segment relationship tells us that the product of each chord is equal to each other. And what this means is that if we look at segment AB and its components, we have A, E, and E, B. So if we multiply those two parts together, that has to be equal to the product of the two segments that make up the other chord. So on chord CD, that's made from segment CE and ED. So a few different ways to represent this. What I usually like doing to simplify this a little bit is marking those lengths for each segment with a variable. So I would call AE little a, EB little b. They're on the same chord. A times B. That has to be equal to the other two parts. So CE I mark with a little c. ED I mark with little d. Okay, so C times B. Okay, so the product of one chord has to be equal to the product of the other chord. Okay, using the chord-chord segment formula, what we want to do here is solve for x. So looking at one of the chords, I'm going to highlight in yellow. The two components that create that chord are 12 and x. Okay. The second chord is created with 9 and 8. Again, using the way I like to do this, I usually mark little a, little b on the same chord, little c, little d on the other chord. So the product A times B has to be equal to C times D. So substituting in, we will have 12 times x equals 9 times 8. 12 times x is just 12x. 9 times 8 is 72. And then dividing both sides by 12, we end up with x being equal to 6. Another example for you. A chord-chord relationship. Go ahead and highlight our two chords that we have. So first chord is made up from x and 20. The second chord is made from x plus 6 and 5. So again, on the same chord, I mark little a, little b, the other chord, little c, little d. It doesn't matter really which one is a, b, and then c, d. So following our formula for the first chord, we multiply the parts. It has to be equal to the other chord's parts multiplied together. So A, substituting, we have x, B is 20, C is 5, and careful here, D is a binomial, so we have to make sure that 5 gets multiplied to both of those parts. So we do need to distribute the 5 when we solve. Okay. So x times 20 is just 20x, 5 times x is 5x, and 5 times 6 is 30. Solving for x, let's go ahead and get all of our x terms to the same side of the equation. 15, get x is equal to 2. Right, so that's the chord-chord relationship. The next relationship that they talk about is the secant-secant segment relationship. Okay. And this formula works with the external and the internal parts for each secant segment. Okay. Formula, I'm going to write this a couple different ways for you guys. One way to look at it when we specifically look at, say, the first secant segment, it wants us to take the outside portion and multiply that by the whole segment. Okay. Outside times whole. This has to be equal to our other secant segment. And it's the same idea. We want to take the outside of the segment and multiply it by the whole distance. Okay, similar to the chords, I do like to again introduce smaller variables to represent the different parts. So I'm going to choose little a to represent the length of AB, little b to represent the length of BC, little c for segment AD, and then little d for the length of DE. So kind of generalizing this formula here, on the yellow secant segment, the outside is A, and we're going to multiply it to the whole segment, which has to be A plus B. Okay, similar for the green segment, the outside or external part is C. The whole thing, we'd have to combine the distance of C plus D. Right, so that's the formula I like to use. And again, I label the components before I substitute and then solve. Okay, so a couple examples here using the secant-secant segment formula. We want to solve for x. Again, generalizing that, I'm going to go ahead and use A times A plus B equal to C times C plus D, where A and C are the external parts for each segment, secant segment. So I can let 8 be little a, x is going to be b, 6 is little c, and then 18 is little d. And so substituting in, we'll do 8 times 8 plus x equals 6 times 6 plus 18. Right. So on the left side, you do have to distribute because you have the variable inside the parentheses. So 8 times 8 is 64. 8 times x is 8x. On the right side, you don't have any variables. If you want to distribute and then combine, you can. Otherwise, this could really all just be typed into your calculator, and we do end up with 144. So solving for x, let's go ahead and subtract 64. And we end up with 80. And then dividing both sides by 8. So our x value is equal to 10. An Ingenuity program might ask you guys to substitute your x value in to solve for a specific length, so please just pay attention to the directions and read those very carefully. I do have a second example to go over with you. Again, it's two secants because they intersect the circle twice. So for formula, a times a plus b equals c times c plus d, so the outside times the whole secant segment. So we can maybe let 4 be little a, little b, 5 is little c, x is little d, and then substitute. So we will end up with 4 times 4 plus x plus 7 5 times 5 plus x. So since we have variables on both sides within those parentheses, you do have to distribute on the left side and the right side of the equation. So we'll go ahead and end up with 16, 4 times 4, 28, 4 times 7, right, so that's just the distribution. On the left side, you do have like terms, so we can combine the 16 and the 28. We end up with 4x plus 44. Okay. I'll go ahead and subtract 4x from both sides. Okay, so we have x, and then our last step, we could subtract 25 on both sides. So the value of x should be 19. Okay. The last relationship that they review is called the secant-tangent segment. That's when you have one secant line, again, touches the circle twice, and then one tangent line, it only touches the circle once. Okay. For this formula, again, a general outline here for the secant segment. What they usually have you guys do is take the outside, and you're going to still multiply it by the whole secant segment. And that's going to be equal to the tangent segment to the second power, or the tangent segment times itself. Okay. Using letters to try to make this a little simpler for you guys, on the secant segment, I'm going to let AB be little a, BC, little b, and then the length of AD, little c. So putting this more in general terms, you're going to take the outside a times the whole secant segment, which is a plus b, and that's going to be equal to the tangent segment squared. Okay, so a times a plus b equals c squared. Okay. A couple examples for you guys running through this. So you use the secant tangent formula, solve for x. So a times a plus b equals c squared. Again, c is always your tangent segment. So in this diagram, our tangent segment is going to be the x value, so that's the c. So on the secant segment, outside is a, inside is b, and then we can substitute. So let's have 5 times 5 plus 16 equals x squared when we substitute that in. Again, on the left side of the equation, you don't have any variables. We can distribute if we want, or just type all of that in to the calculator at the same time. We should end up with 105 either way. And then in order to solve for x, we want to square root both sides. And square root of 105, we get 10.25 when we round to the hundredths place. And that's our approximate answer for x. And then another example for you all. A times a plus b is equal to c squared, where c is your tangent. So in this diagram, our tangent line, again, touches the circle once. It's going to be 12. So that is the c value. A is the outside part of the secant. B is the inside part of the secant. Substituting in, we have 6 times 6 plus x. Our c squared is 12 squared. Distributing on the left side, we'll end up with 36 plus 6x. 12 squared is 144. Let's go ahead and subtract 36. $108, and then divide by 6. So x is equal